Hi, I'm Paul Kyogan from GK Tuition, and in this video I want to talk to you about area, volume and measurement. Now the question we're looking at here is 2018 paper 2 question 7. The first part of this question, it gives us a garden railing, and there's 9 different railings labelled A to I. Each one is a metal bar with a sphere at the top, and you'll notice that as it goes from A to E, the first 5 railings are increasing in size and then decreasing in size. Now, one thing you should hone in on is it tells you that as it's increasing up to E, each one is 1.75 times the volume of the previous one. If each one is 1.75 times the volume of the previous one, you should realize that the volume of the spheres is a geometric series. If you multiply the volume by 1.75, you get to the next one. So the common ratio of the first 5 is 1.75. Obviously, it only applies as you get to E because then it starts to decrease. So with that in mind, then it tells you the radius of the first sphere is 3 centimeters. And it asks you to find the sum of the volume of the first 5 spheres. So there's a number of ways of doing it. Probably the easiest way is, the first thing you do is you get the volume of the smallest sphere. If the volume of the first sphere is 3 centimeters, if the radius of the first sphere is 3 centimeters, it's relatively straightforward to get the volume. According to the log tables, the volume of a sphere is 4 over 3 pi r cubed. So if you just sub in, you work out that the first sphere is 36 pi centimeters cubed. Okay, so that's the volume of the smallest one. Now, you know that in order to get the volume of B, you can just multiply by 1.75. And again and again and again. So you can get the volume of the first 5 of them and add them together. But probably a quicker way of doing this is to use the formula for Sn, the sum of the first 5 terms in a geometric series. The formula for Sn in your log tables is Sn equals A times 1 minus or to the power of n over 1 minus or, where A is the first term, or is the common ratio, and n is the number of terms. In this case, I know the first term, or the volume of the first sphere, is 36 pi. The number of terms is 5, because I'm trying to find the volume of the first 5 spheres added together. And the common ratio is 1.75, because the volume of each one is 1.75 times the previous one. So if I know n, I know a, and I know or, I can just sub straight into my formula. So you'll notice here I subbed into my formula and I got 2324.238 centimeters cubed. But the question said to leave it to the nearest centimeter cubed. So the volume of the first 5 spheres is 2324 centimeters cubed. So your final answer there is this. In the second part of this question, we're concerned solely with the 5th railing, just the railing E. We're told that from the ground to the top of the railing is 120 centimeters. That is the metal bar and the sphere on top of it. And we're told that the surface area of the sphere is 503 centimeters squared. Use this information to find the height of the metal bar. In other words, the distance from the bottom of the sphere to the ground. So obviously what I want to do in this case is I get my 120 and I want to subtract the diameter of the sphere. If I know the whole distance is 120 and I just subtract the diameter, I'll just be left with this bit here. So in order to do that, in order to get the diameter, I must first get the radius. And I can get the radius based on the information I was given here. The surface area of the sphere is 503 centimeters squared. So according to your log tables, to get the surface area of a sphere, the formula is just 4 pi r squared. But I've been told that the area is 503, so I could just sub that in for the left-hand side. If the area of a sphere is 503 centimeters squared, I can work out the radius. Because here I've got one equation and I've got one unknown. In order to get r on its own, or r squared on its own, I just divide both sides by 4 pi. Which means the left becomes 503 divided by 4 pi, while the right is just r squared. Now obviously I have no interest in r squared, I need r. So to get rid of the squared, I just get the square root of both sides. Which means on the left, I get the square root of 503 over 4 pi, and on the right, I'm just left with r. Now obviously I can just plug that into my calculator. If you plug all this into your calculator, your radius works out as 6.3267. So the radius, because I know the surface area, I can deduce that the radius is 6.3267 centimeters. Now I don't really have any interest in the radius. What I'm more concerned with is the diameter. To go from radius to diameter, I just multiply it by 2. So if I multiply that by 2, I get 12.653. So I know the diameter of that sphere is 12.653 centimeters. In other words, the distance from the top to the bottom of the sphere is that. The distance from the ground to the top of the sphere is 120 centimeters. So I want to subtract those two to work out the height of the metal pole. So 120 centimeters minus 12.653 centimeters will give me the height of the metal pole. Now the question asked you to leave it to one decimal place. So leaving this to one decimal place, we get 107.3 centimeters. The height of the metal pole going from the ground to the base of that sphere is 107.3 centimeters. Okay, in B part 2, we're going back to the original railing A. And this time we're only concerned with the bar, the sphere. We're not concerned with the sphere anymore. We're told that the radius of each of the bars in this railing is 1 centimeter. And we're told that the volume of bar A is 71.3 pi centimeters cubed. Now obviously you need to consider that the shape of this bar is a cylinder. So really each one is a cylinder, a really narrow cylinder with a sphere on top. So we've been given the volume and we've been given the radius, which means we can work out the height. Just bear that in mind. It then tells me that the heights form an arithmetic series. So if we can work out the height of the first one and the height of the fifth one, we'll be able to work out the height of all the ones in between. We already know the height of the fifth railing is 107, or the height of the fifth bar is 107.3. So if I can get the first term in this arithmetic series and I have the fifth one, I'll be able to get the other three. So you should realize, right, we're talking about a cylinder. The volume of a cylinder is given as volume is equal to pi r squared h. They've told you the radius of this cylinder is 1 and the volume of this cylinder is 71.3 pi. If you know the volume and you know the radius, you can sub in and find the value of the height. So the only unknown there is our height. So on the left hand side I subbed in 71.3 pi, and on the right, instead of the radius, I subbed in 1. On this line I can just divide both sides by pi and I get 71.3 is equal to the height. So the height of railing A is 71.3. And I know that the height of railing E is 107.3. You can use this information to work out what's the common difference in this arithmetic series, and by extension then I can work out the heights of the first five cylinders. We did this in class a number of times, so you should hone in on this. Remember, in any arithmetic series, the first term is equal to A. That's just what we call it. The second term is the first term plus the common difference. The third term is the first term plus the common difference again. The next one I add the common difference again, I add the common difference again. In other words, in any arithmetic series, the first term is always referred to as A, while the fifth term could be referred to as A plus 4 times the common difference. And I know both of these. I know that the height of the cylinder in A is 71.3, while the height of the bar or the cylinder in E is 107.3. So I can use this to work out the common difference. Really all I need to do is, on the second line here, I can just sub in an A. So I know if I just sub in A instead of 71.3 instead of A, I'll get 71.3 plus 4 times D is equal to 107.3. Now in order to get D on its own, I just divide both sides by, I subtract 71.3 from both sides. In which case I get 4D is equal to 36. Divide both sides by 4 and I get D is equal to 9. In other words, the common difference in in this arithmetic series is 9 centimeters. So once I know the first term, I can work out the next ones. Because look at this. If I know the first term is 71.3, the second term, or the height of the cylinder at B, is just that plus my common difference, which will give me 80.3. And then I just add the common difference again. The next one will have to be 89.3. Add the common difference again. I just add on 9. I get 98.3. Add the common difference again. I add on 9. And the last one, the fifth one, is 107.3. So that's what we need to do in that case. The whole point was to work out your common difference. Okay, in part C, we're given this diagram. Again, we've the 9 railings, and this time they're between 2 walls. And the distance between the 2 walls is 150 centimeters. We're told that the distance from the wall to the first one is 20 centimeters, and the distance between the wall and the last one is 20 centimeters. They reiterate that the radius of each cylinder is 1, which means the diameter of each cylinder is 2. So each of those, I've labeled each of them in as 2 centimeters. We're then told that the gap between each of these railings is the same. And I've labeled all of those as X. So there's 8 different gaps and they're all the exact same. Using that information, we can find the value of X. First of all, right, it's 150 and we need to subtract all the distances we already know. The distances we already know are we've got 20 on the left, 20 on the right, and then we've got 2 centimeters 9 times. So we've 9 cylinders, each that are 2 centimeters wide. So 20 plus 20 plus 2 by 9 gives me 58 centimeters. So that I know of. If you exclude the X's, then it's 58 centimeters. If the whole thing is 150 centimeters, I just subtract it. 150 minus 58 leaves 92 centimeters remaining. So all of these gaps that are unaccounted for at the moment, if you added them all together, they'd be 92 centimeters. If you add them up, if there's 9 railings, then there's 8 gaps between the railings. So 92 divided by 8 means that each one of these gaps that I've labeled as X is 11.5 centimeters wide. And that's your final answer. That's all you needed for that one. Okay, in the final part of this question, we're concerned with sphere A and sphere B. We're given what's basically a right angle triangle. And we're asked to find the shortest distance between the edge of sphere A and the edge of sphere B. The shaded bit in here. Now there's a lot of things you have to account for in order to work this out. But basically we've already got all the numbers that we need. We've got enough information from the previous parts of the question. If I have a right angle triangle, basically I need to find this distance and then I need to find that distance. Then I need to use Pythagoras' theorem and I'll be able to work out that distance and then the bit in the middle. That's our logic in this question. Now it's relatively straightforward to get the distance or the base. In part C, I worked out that the distance from the edge of this cylinder to the edge of that cylinder is 11.5 centimeters. But I need to go just a little bit further here because I know that obviously what they've marked in here is the center of B. The center of B is directly above the center of the cylinder. And the center of A is directly above the center of that cylinder. So I need to go, the 11.5 only accommodates for the edge of the cylinder, but I need to go into the center of the cylinder. And I know the radius of each of these cylinders is 1 centimeter. So it's 11.5 centimeters, and I need to go 1 centimeter into the middle and 1 centimeter into the middle, which tells me that the length of that side is just 13.5 centimeters. It's 11.5 plus 1 plus 1. I know that base is 13.5 centimeters. Now, I think the trickiest thing here is to work out this height. There's a few things we need to account for. First of all, let's just pretend that sphere A and sphere B are the same size. If they have the same radius, the only thing we would have to account for is the fact that the bar at B is 9 centimeters taller than the bar at A. We worked out the common difference of that arithmetic sequence was 9. So I know that if sphere A and sphere B were the same size, then this height would be 9 centimeters. So the larger bar, I'm definitely raising it up 9 centimeters. However, the radius of sphere A is smaller than the radius of sphere B. And I need to account for the difference between the radii when working out that height. So I've written it out here. To work out what the distance from this corner to the top corner will be, it's the 9 centimeters, which is the difference between the bars, plus the difference between the radii, or in other words, plus the added height. The radius of B is a little bit bigger than the radius of A, so I need to figure out what the difference is and how much bigger the radius is, add it to 9, and that'll tell me the distance from there to there. So that's what I've worked out here. Now, in part A, they told me that the volume of sphere B is 1.75 times the volume of sphere A. We've previously worked out the volume of A is 36 pi centimeters cubed. If I multiply that by 1.75, I get 63 pi centimeters cubed. So the volume of B is 63 pi centimeters cubed. And I can use that information to work out the radius of B. Because according to the log tables, the volume of a sphere is 4 over 3 pi r cubed. So if you know V, you can work out r. So I just subbed in here. Instead of v, I subbed in 63 pi is equal to 4 over 3 pi r cubed. Here I've got one equation, one unknown. I can work out the radius. First of all, I divided both sides by pi, and secondly, I divided both sides by 4 over 3. And I ended up with r cubed is equal to 47.25. So if you get the cubic root of both sides, you end up with the radius of b is 3.62 centimeters. So I know the radius of b is 3.62 centimeters, which that's kind of the last piece of the puzzle. And now I can work out what this distance is. I have to accommodate, first of all, that the cylinder in B is 9 centimeters taller than the cylinder in A. So this distance will be at least 9 centimeters. But then I also need to accommodate for the increase in radius. The radius of sphere A from the first part of the question is 3. So if the radius of sphere A is 3 and the radius of sphere B is 3.62, that's an increase of 0.62 centimeters. So I need to accommodate for that. That means that the distance from here to here, in other words, the increase in height from the center of A to the center of B would be 9 centimeters plus 0.62 centimeters. Now if you add them together, you now know that that side must be 9.62 centimeters. So I know the distance from there, the base of it is 13.5 centimeters, the height of it is 9.62 centimeters. I know that the distance from there to there is 3.62. The distance from here to here is 3. So if I use Pythagoras, I'll be able to get the total distance there, and I'll be able to work out what the length of the rod is. So try this yourself. Try and use your Pythagoras theorem before you watch the end of the video. Okay, so based on the previous slide, I know the distance from here to here is 13.5. The distance from here to the top is 9.62. The radius of A is 3. The radius of B is 3.62. My only unknown here is x. But I can use Pythagoras theorem to get this whole distance and then subtract those two radii and work out what is the distance x between the two spheres. So I get 13.5 squared plus 9.62 squared plus h squared, and I end up with h is equal to 16.576. In other words, the distance from the center of sphere A to the center of sphere B is 16.576. But I'm looking for just the distance between the spheres. So if I subtract 3, the radius of A, and I subtract 3.62, the radius of B, I end up with 9.956 centimeters. Now the question asked you to leave this to one decimal place, so if you round that to one decimal place, you get 10 centimeters. So I hope that video made sense. If there's anything you're unsure of there, or you want me to clarify it or explain it differently, then just let me know in class or send me an email, and I'll try and work something out.